In the previous video, you just learned how to find the derivative of a natural exponential function, which would have a base of e. Well, what we're going to do in this video is finding derivatives of unnatural exponential functions. So at the end of this lesson, you'll be able to find the derivative of an exponential function with a base other than e. Alright, so let's go ahead and find the derivative formula. If we have the derivative of a to the x, so a is some sort of constant, 5, 2, 7, 8, it just is not e. We're going to let u be a differentiable function of x, and I am going to actually start with this first one we'll save for just a minute. If y equals a to the u, then when I take the derivative of it, y prime will equal, just like we do with e, if you remember the derivative of e to the u was e to the u du, this one is going to be a to the u du, but we're not done until we multiply by the natural log of a. Alright, and then on this one, if we have y equals a to the x, keeping in mind that x is our u, y prime would just be a to the x times our du, well du in this case would be 1, and then times the natural log of a. So that would be our derivative. And one thing I just would like to point out, we really are using this property when we do natural exponential functions, because when we do the ln of the base, ln of e just ends up being 1. So that's how this formula actually works. Okay, let's do a couple examples. This says to find dy dx of y equals 9 to the negative x. So again, we have our base other than e. It is a constant, which is great. So this is going to be our a value, and this is going to be our u value. So a will equal 9, u will equal negative x. So when we're taking the derivative, so dy dx will equal a to the u. So a to, that did not work out. A to the u, so it's going to be 9 to the u, and then times du. Well, the derivative of the u, the derivative of negative x will be negative 1, and then times the natural log of the a, so natural log of 9. And so then just cleaning this up a little bit, we could go ahead and put the negative 1 out front, because that's usually where we write negative powers, or excuse me, negative numbers. So we have dy dx equals negative 9 to the negative x times the natural log of 9. So that's what my answer would be. And you can't simplify it anymore from there. Okay, and then number 6, we have find dy dx if y equals 3 cosecant x. So again, we have an exponential function. The base is 3, so it's other than e, and our u is going to be the cosecant of x. So 3 is our a, cosecant of x is our u. So when we're finding the derivative, dy dx equals a to the u, so it will be 3 to the cosecant x, times du, the derivative of the cosecant x would be negative cosecant x cotangent x, and then times the natural log of a, so it will be the natural log of 3. Alright, and then just cleaning this up a little bit, we generally like to write the negative in the front of the problem, so my dy dx equals negative 3 to the cosecant x, and then cosecant x cotangent x, and then ln 3. And it really can't be simplified from there. If you wanted to write it in a different order, that would be fine, but that's pretty much it. So it's very similar to e to the x. We just have that one little extra step when we're doing that. So hopefully now you can take the derivative of an unnatural exponential function.